2025, the year forensic science leapt forward while we debated PPE. By Richard Jonathan O. Taduran, Ph.D. Scientific breakthroughs rarely arrive in neat intervals, but 2025 came surprisingly close. Around the world, forensic science advanced in ways that only a decade ago still belonged to speculative conferences and grant proposals. New materials analyses reshaped how we read ballistic evidence. DNA technologies pushed further into the territory of near-impossible identifications. Digital forensics expanded faster than courts can interpret, and AI, for better or worse, continued its slow but steady migration from buzzword to infrastructure. The momentum was unmistakable. Laboratories modernized, research teams pushed boundaries, and entire subfields recalibrated their expectations of what is possible. Innovation this year was not incremental, it was architectural. It forced professionals to reconsider workflows, evidence hierarchies, and even the definition of an investigator in the age of automation. Meanwhile, here in the Philippines, we spent the year locked in spirited debates about PPE and why we should not contaminate crime scenes. Let's take a look at what everyone else has been up to. Forensic breakthroughs. One of the most striking developments of 2025 came out of Ireland, where researchers finally cracked a problem long treated as unsalvageable, recovering fingerprints from fired brass ammunition casings. The conventional wisdom was simple. Once a bullet is fired, the extreme heat and mechanical stress obliterate friction ridge detail. But new methods proved otherwise. Scientists succeeded in lifting usable fingerprints, even from shells exposed to high temperatures, potentially transforming firearm-related investigations. Breakthroughs also emerged in gunshot residue detection. A newly developed approach significantly improved the reliability of identifying residue at crime scenes, reducing false negatives and strengthening early-stage investigative leads. This matters more than most people realize. GSR is often the first clue that turns a chaotic scene into a coherent narrative. Enhancing its detection sharpens the entire investigative process. But nowhere has progress been more visible than in forensic genetics. Around the world, labs continued to expand the use of advanced DNA profiling, including next-generation sequencing and even single-cell analysis, allowing investigators to separate mixed samples that once confounded traditional STR profiling. Alongside this, forensic genetic genealogy surged. From the US to Europe, decades-old cold cases saw movement as genealogical databases, carefully regulated, helped identify unknown suspects or victims. Alaska's crime lab, for instance, used improved DNA testing workflows to revisit bone evidence and illuminate long-dormant cases. France reported similar successes, reflecting the normalization of genealogical approaches in mainstream forensic work. Taken together, these breakthroughs show a world racing forward, not hesitating, not stuck, but accelerating. AI plus forensics. No trend defined 2025 more than the integration of artificial intelligence into forensic workflows. Across digital forensics labs, AI and machine learning systems became indispensable for sorting massive datasets, recognizing patterns in fraud and cybercrime cases, and triaging evidence that would take humans months to parse. What used to require armies of analysts now begins with trained models capable of clustering, classifying, and flagging suspicious digital traces with astonishing speed. The integration isn't magical, it's infrastructural. AI augments human judgment rather than replaces it. It clears the cognitive clutter so analysts can focus on interpretation, not file hunting. In fields drowning in data, online harassment cases, encrypted messaging extractions, large-scale financial crimes, this shift was not just helpful, it was necessary. But perhaps the most intriguing frontier is medicine's intersection with forensic science. Research teams this year proposed AI-assisted systems for death investigation, including models capable of helping determine cause of death from post-mortem data. Early experiments suggest that such systems could provide standardized interpretations, reduce inconsistencies, and support understaffed medico-legal offices. In countries with severe shortages of forensic pathologists, a problem the Philippines knows all too well, AI-assisted autopsy tools promise more than convenience. They offer continuity. These systems are not replacements for experts, but they are becoming essential companions. And they hint at a future where data-rich, algorithm-guided forensic medicine becomes the norm rather than the exception. Systemic challenges. Not everything in 2025 was progress. Some of the sharpest warnings came from countries with the most advanced forensic infrastructures. In the UK, a parliamentary inquiry concluded that the forensic science system in England and Wales is in crisis. Over-reliance on police-run forensic services, under-regulated private labs, and weakened independent oversight have increased the risk of evidence mishandling and potential wrongful convictions. The report was blunt. The integrity of forensic evidence, the bedrock of justice, is vulnerable. At the same time, global reports showed that many crime labs are struggling under rising caseloads. Paradoxically, the more sensitive and powerful forensic technologies become, the more evidence they generate, and the more analyses are required. Backlogs grow, funding lags behind demand, and justice slows. Alabama's crime lab, for example, reported delays driven not by incompetence, but by structural under-resourcing. These systemic issues reveal a hard truth. Even in countries with world-class forensic science, infrastructure, governance, and investment determine the difference between innovation helping a society or overwhelming it. Which brings us back to the Philippines. While the global forensic community grapples with the ethics of genetic genealogy, the workload implications of next-generation sequencing, and the governance of AI-assisted autopsies, our national conversations still orbit the basics. Based on all the public lectures and media interviews I have given this year, we are still debating PPE compliance, chain of custody fundamentals, and whether criminology and forensic science are the same thing. The one bright spot, of course, is the launch of the National Forensics Institute, a long overdue step toward professionalizing the field, though it is far too early to know whether it will be empowered to meet the country's needs, and it still has to work its way through the bureaucracy to avoid overlapping with other agencies. In 2025, the world moved toward the future while we continued to negotiate the starting line.